Okay, hey y'all. We are going to look at a couple of functions. We're actually going to be able to tell if it is a function, and we're going to be able to tell what the degree of that function is. Don't know why I have that. That should actually say 3.2. Let me see. Oop. I believe 3.2 is quadratic functions and their graphs. I think I was going to do a 3.1 video. I technically already have all of those done. There as in there's, not there as in over there. Quadratic functions and their graphs. Okay. So the beginning of the homework, what it does is it asks you to determine if a function is a function, right? If our f of x, if what they give us is a function. And if it is a function, what is the degree of that function? So our degree is the highest exponent. So say we have x of n, it's being raised to the n power, right? The nth power. Whatever is our highest n, that is our degree. Now it's very important right here. This is where n is a non-negative integer, okay? If it is a non-negative integer, then it is a function and we can state what the degree is. If it is not a non-negative integer, then we would say that it is not a function. And then we wouldn't even need to identify its degree, okay? So if I look at f of x equals 3x squared plus 4x to the fifth, I notice that my highest exponent is a 5. All of my exponents are non-negative integers. Therefore, yes, this is a function, and its degree is 5. Okay, so this, it's because it asked, is it a function? This is its degree. Okay, so let's scoot over to the right. Right here, I have f of x equals 7x to the fourth, a positive 2x cubed, and a positive 4 over x. So I need to remember my exponent rules. You wouldn't want to have your x in the denominator. And so for this particular problem, I would basically apply the negative exponent rule here, which basically just states that if you have a variable raised to a power and it's in like the numerator, you could bring it down to the denominator, and what it does is it changes the sign of the exponent. You know what? Let me do this right here. If we have, let's say, a raised to a negative power, you can write it as 1 over a to a positive power. So just understand that the equal sign literally means equivalent. I can start on the left-hand side and I can change it mathematically into the right-hand side and vice versa. What I noticed for my last term is 4 over 7 is just like having that ace raised to the nth power in the denominator. And my exponent rule says that I can write it in that manner. As long as you remember that you need to change the signs whenever you change its position. So what I would notice here is if I actually looked at my 4 over x, this would need to come out of the denominator, which would make it 4x to the negative 1. And so I noticed that my exponent is not a non-negative integer. It actually is negative. So no, it's not a function. There is no degree to this because it's not an actual function. Okay, so let's look at the bottom left. Here I have x to the 1/2 power plus 5x plus 6. So I know that it had told me that my degree is going to end up being the highest exponent. It looks like I have a half and I have a 1. So I need to read that highlighted sentence. This is where n, our exponents, are all non-negative integers. X to a fractional power is not an integer. That's a rational power. So because it's not an integer, that means no, it's not a function. Hey, will y'all shut that door, please? And then let's look at the bottom right function. What we have here is a binomial being divided by x cubed. As long as, I'm trying to find a way to say this to where it makes sense. Because of that operation in the numerator, y'all, that positive sign, that plus sign, you can't cancel. Y'all can't just, use an exponent rule or just simply draw a line through your x's. You can't do that because of that operation. But what I notice is if I have a binomial written over the same term or just the same denominator in general, it doesn't matter how many terms are in my denominator. If I have something written over the same denominator, you can actually separate. This is technically two fractions. Because they have a common denominator, I'm able to write it that way, right? You would keep the common denominator at the top terms, your numerators, because those aren't like terms. They can't actually be combined. So that's why you just get the x squared plus 3. Now we can actually do something, right? Now that we've separated it, I can use the exponent rules on that first fraction. And I know that the exponent rules, when you divide variables, what you do is keep and subtract. And then we would have the rule that we just did here, which is if it is being pulled from the bottom up to the top, you change the sign on the exponent. So both of these exponents are negative, and I needed to be looking where n is a non-negative integer. So no, this is not a function. Okay, so it could show you some graphs, and it would ask you if they're functions. The way we know if it's going to be, like if this polynomial, if this graph of a polynomial is a function, would be if it's smooth and continuous. Smooth meaning there's no like jagged turns or sharp corners, and then continuous meaning, I want to do one more, and then continuous meaning doesn't really matter what my endpoint looks like. Let's just say this. And then continuous meaning that you could trace it with your pencil and you would never have to lift up your pencil. So in other words, it's not discontinuous. Okay. If we were to look at the one I just now drew, that's actually a graph of the absolute value function. And right about here, that has a sharp turn very abruptly at the origin. And because of that, this would not be. Okay, and then let's look at this first one. If I put my pencil on this graph and I draw it, never do I need to pick up my pencil, and never did I actually trace any sharp edges. Therefore, it's smooth and there's continuity, which means yes. Yes, it is. Okay, if we do this one right here, if I wanted to actually trace this graph, I've got that portion, and then I have this portion, and then I have this portion. So I actually had to lift my pencil multiple times, but lifting it at all makes it not, okay? And then this last graph. If I trace it, I have to stop here because that open circle actually means that that is not a point on the coordinate plane that is included in this graph. And then I would pick it back up right here. Like I would pick it up for the open circle. I'd actually put it back down there, but I'd pick up again where that graph left off on this bottom line right there. Noticing that there is a space that wasn't colored on and that I had to lift my pencil means no, it is not. Okay, y'all. Now I'm going to do another one. Bye.